Hi, my name is Justin Eichel, and in this short video, I'll be talking about the physics behind gridiron football. Over the years, football has become the most popular sport to watch in the United States of America. Super Bowl Sunday has turned into somewhat of a holiday for most Americans, with over 100 million people watching every year. But just how did this sport explode into what it is today? Well, the first game of football was played between the college teams of Rutgers and Princeton in 1869. However, at the time, the rules of this game were very similar to the rules of soccer, except with 25 players on each team. The game gradually evolved into something that resembled rugby rather than soccer. Eventually, Walter Camp, hailed today as the father of American football, established the snap, 11-player teams, and the line of scrimmage. What really set this sport apart from rugby, though, was the implementing of downs, which meant that the team had a certain number of chances to progress on the field, or else they would lose possession of the ball. I personally do not currently play organized football, but I believe that just throwing the ball around in the backyard with some family and friends is an enjoyable way to pass the time. I am also a really big Detroit Lions fan, and I have been for my whole life. Football games today usually start with a coin flip. This coin landed heads. Looks like we're starting on offense. One of the biggest roles in a football game is that of the offensive lineman. His job is quite simple: protect the quarterback. When you watch these linemen clash, physics probably isn't something that you think of. However, physics is present and it is crucial to the success of the lineman. Every person has a center of mass. This point on the object will move in the same path that a single particle would move if subjected to the same force. The mass of a lineman is concentrated in this point. All bodies will rotate easiest about their center of mass. So, if a force is applied on either side of the center of mass, the object will rotate. This rotational force is called torque. Here is the equation for torque, where F is the force, d is the distance from the force to the axis of rotation, also called the length of the lever arm, and theta is the angle between the direction of the force and the direction of the lever arm. Since torque is a product, it is clear that less force is required farther out from the center of mass than closer to it. In other words, as d increases, F is able to decrease and the same torque can be achieved. Coaches use this logic and advise linemen to stay low. Their center of mass is located right above their hips. Staying low brings their center of mass closer to the ground, so an opposing player can only contact them near their center of mass. This makes it difficult for an opposing player to move them, as they will not rotate easily upon contact. This effect is shown here, as the person who keeps their center of mass lower to the ground is much harder to move than the person who rises up. Staying low also provides an advantage when blocking, because it allows the lineman to rise up. This allows him to impart a bigger torque on his opponent, since the distance of the lever arm increases. Unfortunately, a touchdown wasn't scored on this drive. Now it's time for a field goal. Once again, physics is crucial here, but this time in the form of projectile motion. A projectile is any object that has been fired, thrown, or propelled such that it has no capacity for self-propulsion. The object is under the influence of gravity only. Projectiles follow parabolic curves. In this case, there is motion in two directions, vertical and horizontal. For horizontal motion, the initial velocity Vix is the same as the final velocity Vfx. Also, there is no horizontal acceleration, so a is equal to 0. Therefore, the complicated UAMs in the x direction simplify into this one equation. The thing the x and y directions have in common is time t. Therefore, if we solve for time in the x direction, we can use it in the y direction as well. To solve for time, we just need the velocity of the ball in the x direction and the distance to the target or change in x. To get the velocity in the x direction, we just need to know the actual velocity and the angle at which the ball is kicked. Using a triangle, vectors, and trig, we can solve for the velocity in the x direction. Once time is found, it can be transferred to be used in the y direction UAMs. In the y direction, acceleration is 9.81 meters a second squared towards Earth, which is gravity. The initial velocity in the y direction, VIY, can be found using the same method as VIX, which was the initial velocity in the x direction. Finally, once all values are obtained, we can find the change in the y direction. Once the change in y has been discovered, this can be compared to the height of the field goal post to determine whether or not a field goal is a viable option for a coach. This is projectile motion in action.
fire. Give me reason, take me higher. See the champions take.
Once again, my name is Justin. Thank you for watching. Hopefully you guys learned something new and have a great summer.